at home. Today I wanted to go over, in this video we're going to go over chapter 9, section 1, so 9.1, the first section of our new chapter. We're going to move on from quadrilaterals, although we'll see a little bit of those. And we're going to talk about actually moving figures around on the page. So let's go ahead and get started. I'm going to go ahead and share my notes with you. Hopefully, there we go. All right, so the 9.1 is actually called Translate Figures and Uses. So what I want to talk about is kind of a general thing first. And the first thing I want to talk to you about is something called a transformation. Okay, so a transformation, we've talked about this before. Transformation. So a transformation is when we take a shape, an object, and we do something to it, like we can either move it, which we call translation. We can rotate it, we can reflect it, and we can enlarge or reduce it. So a transformation can, oops, not a line through there. A transformation could be multiple things. It could be moving, which we call translation. Okay, it could be reflecting. It could be rotating. And it could be enlarging or reducing. So those are all types of transformations. And we've talked about this before in earlier sections. We usually have like a section right at the end about this. So that's just kind of a review of what a transformation is so that we can talk about that. The other thing I wanted to review with you, I think we've talked about this before, but in honor of Valentine's Day. So let's say we have a heart, right? And I move that heart to a new spot on my screen, which would be a translation. Okay. So what I've done is I've moved this over. This is my original. And this is my new spot. So what I want to review with you is some terminology. So we call this original shape, this original figure, we call this the pre-image. Okay, and then we call the new shape, the new figure, we call this the image. So these are the two words I want to review with you. The new is the image, the original is the pre-image, and those are the first two vocab words you'll see up here. The image is a new figure produced by the transformation of a figure, and the pre-image is the original figure. So that's this example that I just showed you with the heart is an example of a pre-image and an image using translation. It could also be a rotation, right? So we've talked about this in the past. If this was our pre-image and I rotated our pre-image 90 degrees clockwise, the new image would be the sideways. So this would be the image. So I just want to make sure that we all remember that so that when you're reading these different things that you have an idea of kind of what's going on. So in 9.1, actually what we're really interested in is we're just interested in moving things, which we're calling translations. So we're not going to talk about reflection, rotation, enlarging, reducing in this section. We're just focusing on translation. So translation is this example here where you have an object, an image, a shape, and you're just moving it to somewhere else. So we're going to talk about translations and all the different ways that we can basically use math words to translate. So this section is actually really easy. It's really just all about understanding the terminology behind it. Okay, so let me, now that I wrote all over everything here, let me back up a little bit here. So the first thing that I want to tell you is that we have a theorem, okay? And this theorem is theorem 9.1. It's a super easy theorem. And it says, it's the 9.1, theorem 9.1 is the translation theorem. And what it says is, it says a translation is an isometry, okay? So that's a new word for us too. Isometry, as you'll see up here, an isometry is a transformation that preserves length and angle measure. So first of all, did you know there was a word that rhymed with geometry, right? We've got isometry. Second of all, the idea of isometry is kind of So isometry is a transformation that preserves length and angle measure. It's kind of like saying that it's going to be congruent, right? Because if two different shapes have the same length and angle measures, we call them congruent. But since we're talking about transformations, in transformations, we don't use the word congruent necessarily. We use the word that we say that it has isometry. So when we're talking about that's transformations overall. When we're talking about translation specifically, where you have an original image and a new image, and it's moving and it's the same, we say that that's always an isometry. Okay, so it's really just kind of like a definition of what a translation is. So down here, what you'll see is going on is we have this original triangle ABC, okay, and it's moved to a new spot over here. So now it's to the right and up a little bit. And so now it's triangle ABC again, but you'll notice these little, it's really hard to see on the screen, these little tick marks here, which we call prime. So this is triangle ABC is congruent to triangle A prime, B prime, C prime. So notice we use the symbol for congruent, but we use the word isometry basically to indicate that when you have a translation, it's isometry. So translation again is moving. Transformation can be multiple different things. So we're just going to focus on, from here on out in 9.1, we're just focusing on translations. That's moving an object to a new spot. So the rest of this section is really about understanding what are some ways that we can graph a translation, what are some ways that we can write rules for translation, and talk about translations. Okay, so that's what we're going to do now. So let me move this out of the way, our heart here. So the first thing that we're going to talk about with a translation is probably going to be some review, but it's good to review. So what I want to do is talk about example number 1 here. Okay, example 1 says translate a figure in the coordinate plane. So it says graph quadrilateral ABCD with vertices at A, B, C, and D. We have those written there. Find the image of each vertex after the translation, and then it gives us the translation notation here, how to translate that. So let's first off, really quickly, we're going to do sentence number 1. We're going to graph quadrilateral ABCD with vertices at these points. So A is at -2, 6, -2, which, excuse me, is right here, the hiccups. B is at 2, 4, right here. C is at 2, 1, and D is at -2, 3. Okay, so this is our pre-image, right? This is our original image, so we call this a pre-image. And then what we want to do is we want to find the image of each vertex is A, B, C, and D, and we want to use this translation xy equals, so this should look familiar, xy, the coordinates xy, translate to x plus 3, y minus 3. Okay, so what that means is that A was at -2, 6. All right, the new spot for A, which we're going to call A prime, A prime is at x plus 3, so -2 plus 3, which is 1, and 6 minus 3, which is 3. That's the new A prime. That's where the image is. The image of vertex A after the translation is at 1, 3. So we can go ahead and graph that on here, 1, 3, and we would say this is where A prime is. Okay. We just can keep doing this for each of the coordinates. So B is at 2, 4. Okay. If I translate it using my translation, right, B prime, that's what this little hash mark means, prime. B prime is at x plus 3, so 2 plus 3, which is 5, and 4 minus 3, which is 1. So it's at 5, 1. Okay, and then we'll keep going. This is where I'd speed up the video if I knew how. C is at 2, 1. C prime is at, I have it written down here, 5, -2. And D is at -2, 3, which makes D prime at 1, 0. So let's go ahead and put those on here. C prime is at 5, -2, C prime, and D prime is at 1, 0 right here. So you'll notice once you graph the image, which is the new, once you graph the image of all the vertices, you'll see that your quadrilateral has been translated. It's been shifted to the right by 3 and down by -3, right? So this is how we would do that. And you'll see there's a little note over here that talks about the pre-image is A, B, C, D, and its image, the new, is A prime, B prime, C prime. So that's this little hash marks mean prime, and that's indicating the new spot. Okay, so that's how we would do that. I think you've all have probably done it before, but again, just knowing the terminology can help out with that. All right, next example that I want to give with this is, what if we have, let me zoom in a little bit here. What if we have a pre-image and its image, and we want to, well, my mouse is, there you are. Okay, so what if I have an image and a pre-image, okay, but I want to I want to write a translation rule. So I wanted to write a translation rule. So in this picture, it's hard to see, but this is A, B, and C, and this is A prime, C prime, and B prime. So I want to write a rule using the translation notation. So translation notation is when I have my original X and Y, and I say that it translates to some X and Y that have been translated. So you'll notice on here, if I look at A and how it gets to A prime, right? I'm going to move, my X is going to move to the left 3 units, 1, 2, 3. So in order for me to go from A to A prime, my X is going to have to go -3 because it's moving to the left on my coordinate plane, right? And then to get to A prime in the Y axis, yeah, it has to go up by 2. So it's got to go up by 2. So this would be the rule for the translation of ABC to A prime, B prime, C prime. Now, notice here it says, then verify the transformation as isometry. Are the two shapes congruent to each other? Yes. And you can also verify by checking one of your other points. So let's go from B to B prime here. Okay, so to go from B to B prime, I need to go -3, +2. So that's where you get your -3, +2. So that's, again, how we can write a translation rule. Okay, so that translation rule that we just talked about, we've already done in the past. It should look familiar to you. But I want to talk to you about something that's kind of new. So the next thing that I want to talk to you about is sometimes, instead of writing a translation rule like we just did, where we have the X, Y translates to, X plus 3, Y minus 6, or whatever it might be. Instead of using that translation notation, what if we are going to use something that is called a vector? Now, if you're in physics class, you might have already talked about this before. So a vector, if you go back to your definition in the front, a vector as a quantity has a direction and a magnitude. So it's not just like how big something is, it's what direction it's going in. So this is an example of a vector. Again, I apologize for the crazy screen, but if I was to draw this right here, what this should look like is this. FG is a vector. FG is a vector because it has a direction. In this case, it's moving up to the right-hand side, right? And it has a direction and it has a magnitude. It's a certain number of units long. I don't know what this is at the top of my head. It's probably around 6 point something. So it has a magnitude, a size, and it has a direction that it's going into. So we're going to talk about what a vector is. How do we talk through my pen? How do we talk about vectors? How do we name them? So this vector right here shows a vector named FG, read as vector FG. Fancy name, right? So let me write this more clearly. So we write the vector like this, FG, and it's got this like line. It's not a ray. It's just got half of a line. So that's what we call a vector. So you'll see here it says the initial point, or the starting point of the vector, is F, and the terminal point or the ending point is G. So it starts at F and goes to G because that's the way the arrow is pointing. So what the point of writing those in is that you could not name this vector GF. That's a no-no, right? Because it's not starting at G and going to F, it's starting at F and going to G. Just like array, you have to always start at the terminal point and go toward the arrow. So that's pretty straightforward. Okay, so that's one way that we can name a vector on a plane. And another way that we can name a vector is we can talk about the components of a vector. So the components of a vector mean what are the x's and the y's that make up this vector. So if I look at FG, to get from F to G, right, I'm moving 5 units to the right. See that? I'm going 1, 2, 3, 4, 5, and I'm going 3 units up. So another way that we can express vector FG is in component form. And component form combines the horizontal and vertical components. So the component form of vector FG is, and we write these brackets like this, we say it's 5 units in the x plane, and we say it's 3 units in the y plane. Okay, so that's, I promise we're going to get to a way for how does vectors use transformations, but this is what is a vector and how do we name it. So let's practice a couple of these because they can get a little bit confusing, okay? So in this example right here, again, apologize for this. So we've got G and we've got H, and we've got an arrow that's going from G to H. Okay, and so it says name the vector and write its component form. So to name the vector is actually pretty easy. So to name the vector, we start at the initial point and go to the ending point. So it starts at G and ends at H, and we put our little vector across the top, and voila, we have a vector. Okay, now the component form takes into account the x and the y, that it takes to go from G to H. So the x part is that we're going to travel 1, 2, 3, 4, 5 units, right? We're going to travel 5 units in the x plane, right? And then we're going to go down 1, 2 units in the y plane. So when we go down in the coordinate plane, that's a negative, right? We go down -2. So the vector, the vector is GH, and the component is 5, -2, and we know it's a vector because of these special brackets here. Okay, let me show you another example. So here, this says S and R. Okay, we would name the vector. This would be vector RS. Again, you want to name it just like you do array. Start at the end point and go toward the arrow. The component form, right? We need to worry about what happens with the x's first. So the x, you'll see, is just right along this line. And it looks like we're going 7 units to the left. So the x part of this will be -7, all right? And the y part of our vector is 0. Right? We're not going anywhere in our y. So the component form will be -7, 0 of this vector. All right, so why are we learning about these vectors? Well, we can use vector form just like we use the translation form. So I want you to kind of think of it this way. It says the vertices of, oh wait, do I have my other thing back here? Actually, I do. So actually, I'm going to make it even easier for you, okay? So I'm going to go back to this example here where we had to translate a figure on the coordinate plane, okay? And remember the translation, I'm going to make this some more bold here, was that x, y translates to x plus 3, y minus 3. So another way that we could have written this translation is I could have asked you to translate ABCD using vector 3, negative 3. Using vector 3, negative 3. So you notice I took the x portion, which is positive 3, and the y portion, which is negative 3, and we put that into vector formation. So it means the same exact thing, right? It means, vector formation, or vector component notation should have the brackets like this. So when I or the book would say to you, to translate an image using a vector, it's basically telling you to do the same thing that you did in translation. It's just writing it in a different format. So you'll notice on here, if I want to go from D, my pre-image, to D prime, right, I am going to go in my X direction, I'm going to go positive 3, and in the Y direction, I'm going to go negative 3. So the vector from D to D prime is going to be the one that goes positive 3, negative 3, and that's how I get to my new image. So to use a vector notation, you're going to do the same exact thing that you would here. So I'm not going to do this whole thing over here, but just to kind of give you a quick example. If your vertices of triangle ABCD are A, B, and C, translate using the vector negative 4, 1. Well, if your your pre-vertice is at 0, 4 for A, right, and you're using vector negative 4, 1, that means that A prime is going to be 0 minus 4, or A prime would be minus 4, right? And then the Y component is going to be 4 plus 1, or 5. Okay, so another way that I could write vector negative 4, 5 is in in translation is I could write x, y translates to x minus 4, y plus 1. So I just wanted to understand how those go back and forth. So that's how you do 9.1. Check out the homework. Let me know if you have any questions, and enjoy your day. Thanks, guys.